Hi everyone. Wanted to show you some additional spreadsheet engineering features based on the Giapetto's wood carving problem. I had shown you a simplified model previously where we translated the basic linear program into this right here. But what I'd like to show you is going straight from the word problem itself. So we have quite a bit of data in here. So we have revenue, we have raw materials, we have costs, we have carpentry labor, and we have finishing labor. For all these, we have a variety of values which are pulled directly from the problem over here: 27, 21, 10 and $9, $14, $10, $1, 1, 2, and 1. This is data. These are all dollars. So we're going to click the dollar sign. We're going to turn those into actual dollars. These are just numbers, so we are going to leave them as is. Okay. We are also going to go ahead and format these as we do, adding a blue border and filling with a light gray background to show that this is given data. We also know that we have to choose how many soldiers to make and how many trains to make. Note, this is all the information related to soldiers. This is all the information related to trains. We are going to go ahead and set up some cells to represent our decision variables. Going to put a nice border on those. It's going to be a nice red border, not that. We want the border. So we have that all set up. And the thing we're doing here is we're deciding the number of each of these to make. Now there is one item I don't have on here, and that is we make at most 40 soldiers. So we are going to put demand here. We're going to put a 40 here. And we are going to say demand has to be less than or equal to 40. This again will follow the same guidelines as our other given data. We're going to go ahead and give it our nice blue border. And we will also fill it with a nice light gray background. There we go. So we have our decision variables, our numbers to make. We have our demand, and we have all of these folks that we have been given. We do have a left hand or a right hand side on each of these, which is less than or equal to here, less than or equal to here as well. And we have 80 of these hours and 100 finishing hours. So we're going to go ahead and do this. Again, we'll come in, give that the good formatting so that it looks nice and is consistent with the rest of the formatting across our spreadsheet. And here we are going to use our sum product. The sum product of the choices we're making with the amount that each takes, just like we did in the previous problem. And I can drag that down, and that's beautiful. Now, the one thing that we are missing here is maximizing our weekly profit. And so generally what I put down here is there's some things I have to calculate. If you remember from our original presentation, the first is revenue. Okay? The second is raw material cost. The other is these variable costs. So I have my revenue, and note how I've set this up. Again, I'm taking the sum product of my decision variables. I'm going to lock those, and I'm going to do the sum product with the revenue, because for every soldier, I have $27 of revenue. For every train, I have $21 revenue. I can now take that and drag that down, and you'll see it translates perfectly, calculating my raw material and costs. Okay? And then finally, I have my profit, which I am maximizing. My profit is simply revenue minus material costs minus my remaining costs. Oops. And we will just, sometimes you get this overlapping, it causes problems. You just go ahead and say minus. You can type in the cell, find other ways around that. So B14 minus B15 minus B16. This we are going to go ahead and format, give it that nice double border that we put on our objective function, and also make sure that these are all formatted as dollar amounts, because that's what they are. Now I can go in and I can say solver. Well, solver, I want to take that cell, I want to maximize it by changing these two cells. I know that my carpentry and finishing labor must be less than or equal to what I have available. I also know that the number of soldiers made has to be less than or equal to my demand. I can check this, make my unconstrained variables non-negative, and say simplex LP. We are maximizing, and if we hit solve, let's see what happens. Solver found a solution. Now this is not correct. Can anybody see why it's not correct? This is because I have a wonderful typo. And if I come back in and solve it again, we are where we should be with our $180 worth of profit. The one thing missing here is that we will also type amount available above our right-hand side. Make this look beautiful. And we are now good to go with a well-formatted, well-engineered spreadsheet that is correct, reliable, communicative, and modifiable.